Great. Well, welcome to the EE Colloquium. I'm Carl Böhringer. I'm a faculty here in electrical engineering, and I'm very excited and happy to have a special guest here today, Kurt Petersen. There is the danger to give a very long introduction, and I'd rather not do that because I want to give Kurt as much time as he needs. But I did want to show one thing. Here's a massive paper that I give all of my students to read when they take my Introduction to MEMS class. So this is almost 40 pages, and maybe not all of them initially appreciated that I give them so much to read in their first week. All right. Kurt wrote this paper or it was published in '82, and it's really an outline of the entire MEMS industry as he envisioned it back then. And it's really amazing how much he predicted at that time and how much he himself has contributed to this community to build it up and make it successful. So Kurt has been, he received a bachelor's degree cum laude from Berkeley, then a PhD from MIT. He went to IBM where he wrote this paper, and in the meantime, he started 6 successful companies in the MEMS and microsensors area. And now he's mostly spending his time in mentoring people, helping them with their startup companies. He's been very generous and very helpful for the entire community. So I'm very happy to have him here today. Thanks very much.
Thank you very much, Carl, for a wonderful introduction. So I started working on this talk, several weeks ago, and the first slide of the talk was congratulations Seahawks, but I pulled that slide out, so sorry about that. I actually rooted for the Seahawks. I watched all the game. It was a sad game. But just a little bit on my background. As Carl mentioned, I started off at IBM Research. And then I sort of got into startup companies. I founded or co-founded 6 companies, had 4 successful exits, and I think Perfuse is going to be a very exciting exit in the next few years. And now I'm with this Band of Angels, which is the oldest angel group in Silicon Valley. There's about 150 people. We see 50 new companies every month. So it just kind of gives you the idea of the volume of the startup companies which are happening in the Bay Area. So this is the outline of the talk. I'm going to give first a brief business status of the MEMS industry, and then some observations on several of my startup companies, and then the current MEMS startup environment, which is very, very different in the last few years than it has been in previous years. So, and I have a lot of examples of MEMS companies that are starting that I'm working with, and sort of how they're dealing with the fact that you can't get early funding, or it's very difficult to get early funding for hardware startups. And then we'll talk about the entrepreneurial outlook for the future of MEMS, which I'm very bullish about. So I like this chart. It's put together by a friend of mine, Janusz Bryzik, and it shows the revenue from the semiconductor industry in blue, the revenue from the MEMS industry in green, and then the ratio of those, the fraction of the semiconductor industry that the MEMS industry has been generating. And what's interesting about this is before, in the 1980s and even into the 90s, the MEMS industry was shipping 1% of what was being shipped in the semiconductor industry. Today, it's up to 4%, and it looks like it's going to climb to 6 or 7 or 8%. So the MEMS industry is growing faster, quite a bit faster than the semiconductor industry, which is very interesting. And of course, there's listed on here all the kind of various products that came online over the years, the digital light projector, the accelerometer, the microphone, gyro and compass, antenna tuner, and kind of as more and more products get into, especially the mobile space. Other thing, first real MEMS meeting in the US happened in Hilton Head in 1984. So that meeting is held every 2 years, and so that was the first one. which came out right when the disposable pressure transducer started becoming a product. So that Hilton Head meeting has been following the progress of the Hilton Head, of the MEMS product introductions as we go on. But the other thing that's really exciting about this chart is, and very interesting, is it's only been really very recently, like 2009, that the first company announced that they had shipped cumulatively over 1 billion MEMS devices. So that was only in 2009, so it's 6 years ago. And now, in recent years, companies have been shipping billions of units every year. So just the growth of this industry has just been tremendous. So what's been the fuel for this growth? Well, I mentioned the disposable pressure transducer. This is a pressure transducer. This is the inkjet printers. This is a gas chromatograph, which is in production. The digital light projector, atomic force microscope. These are all MEMS devices. This is the F-bar filter made by Avago, which is in all of your cell phones. This is the inertial space accelerometers and gyros, which are in all your cell phones. This is a microphone, which is also in all your cell phones. In fact, people are now putting multiple microphones, MEMS microphones, in a cell phone for doing direction finding and for canceling out noise. Huge industry. And this is actually one of my companies. They're making a silicon oscillator to replace the quartz crystal. This company just got sold for 200 million, sorry, I wish it was 200 billion, just last year. And right now, those oscillators, I'll talk more about that, but they're better than quartz in every way. And then this is a variable capacitor antenna tuner for tuning. So your cell phone transmits on so many different bands right now for all the functions that it's doing. And you don't want to have an antenna for each one of those bands. So this antenna tuner allows you to have one antenna and then tune the antenna for all the different bands. So huge fuel for growth in the MEMS area. So what's the future fuel for growth? Well, I think this is really exciting. There are 3 enormous Internet of Things initiatives which are happening. One of them, and I think there are a number of prizes. This is the Qualcomm Tricorder Prize. It's a $10 million prize for developing basically a medical system that interfaces with your cell phone. And so this whole medical area is just a huge area. And then there's this HP Sense, the central nervous system for the Earth, where people are envisioning sensors all over, on cows, on buildings, in the dirt, measuring water, moisture, and earthquakes, and huge Internet of Things, just sensing everything on the planet. And these kind of visions have been melded by this friend of mine, Janusz Brajec, to the trillion sensor roadmap. So that people are starting to put plans in place for how you handle the infrastructure for 1 trillion sensors, distributed all over the planet. And how do you move all that information up to the cloud and do some analysis on that information. So the reason why I'm presenting this way is there's a huge market. Every one of these sensors will have some kind of MEMS component in them. And I think it's just a huge future for sensors and MEMS devices going forward. So I'll talk a little bit now on observations of some of my startup companies. So the first startup I did really wasn't very successful. So actually, that's sort of another part of the message is, don't be intimidated by failure. So my first company was like a total failure, but I didn't go to sleep, or I didn't go back and get a job at IBM. I kept doing startup companies. And actually, Novasensor was quite successful. Our first product was a second source disposable pressure sensor. So in those days, actually, in 1985, this was relatively new. So people used to have these complicated mechanical sensors for testing blood pressure during operations and when people are in recovery. And they'd have to be sterilized after every use. So the silicon MEMS allowed you to have a very low-cost pressure sensors that you could just throw away after you use them. So when we started the company, these were already in production. But we developed a new sensor in response to a customer coming in and saying, we're not getting our silicon chips. our supplier is very erratic. And so we designed a disposable blood pressure sensor, very tight distributions on parameters. We shipped the product as die, so we didn't have to do packaging. And we had higher yields and more reliable deliveries than the competitors. And this was a very simple product, and it was a second source product, but it really got us into production. And when you're in production at a startup company, it's a whole different environment than doing R&D and doing development. So it changes your mentality. So we didn't have a fab, but actually we got into production within a couple of months. We shipped 50,000 die, and 12 weeks after we took our first order. And then Novasensor got into industrial, consumer, automotive marketplaces for pressure sensors, and they were later acquired by GE, and they're now owned by Amphenol. And the lesson I learned at Novasensor, and again, this talk is all about startup companies and commercializing MEMS, is get into production as soon as possible, because it changes the mentality of the company, makes the company thinking about customers, about production, about products. So these are some of the chips we made at Novasensor. We also did a lot of R&D. This is a catheter tip pressure sensor we developed. This is actually a high-frequency voltage detection device. This is a pressure sensor using silicon fusion bonding two wafers together, which was a new technology in those days. This is a deep reactive ion etching together with fusion bonding, just kind of a demo part, catheter pressure sensor. And this is an accelerometer, which we built in the early days of Novasensor. So a vast variety of devices. We developed some new technologies which are being used all over the MEMS industry today. And I put pictures of the team here because, as I'm going to talk a little bit about later, when you start a company, the most important part of the company is the team. And investors always look at the team, and does the team really have the persistence that it takes and the drive that it takes to go forward and to turn that company into a profitable, successful company. So even though it's a little bit silly, and I look a little bit silly after 25 or 30 years ago, but the team is the key part of starting a company. So that's one of the messages I want to get across today. Then we founded Cepheid in 1996. The vision of Cepheid was to build rapid micro-PCR, microfluidic sample preparation for DNA diagnostics. And this is like testing for MRSA. I don't know if you've heard of methicillin-resistant Staph aureus, which is a very deadly infection that people typically get in hospitals, and you need to detect that fairly quickly. You can't just do cultures. There's not enough time to treat the patient. So you have to. So what Cepheid does is looks for the DNA of MRSA in the patients that they're trying to diagnose. So the vision product, we had this vision. We wanted to build this automated diagnostic system you would just put the sample in the cartridge, put the cartridge in the machine, and it would tell you in a half hour whether you have MRSA. But it's really a difficult kind of product to build. It takes FDA approvals, and it takes a long time. So what we did, and it takes a lot of money, obviously. So what we did is the first product was for life sciences research. And we built the Smart Cycler, which didn't require any FDA approvals. We got onto the market. We were selling the Smart Cycler. People were buying it, and it was giving revenue to the company so that we could develop our vision product. So it's a way of quickly getting into the market, quickly getting revenue, and using that revenue to support your home run product. So this home run product was a Gene Expert, and this went into production 7 years after we started the company. And the first application was actually for the US Postal Service. So all of your mail today is screened for anthrax with Cepheid systems. All the US Postal Service sorting centers have these systems. And actually, Kristen Helton right here in the red sweater in the front row played a key part in developing that instrument. And then she left and came up here and got her PhD up here. More about Kristen later. So our first FDA-approved test went into production 10 years after we started the company. So persistence, right? We had $100 million in annual revenues 10 years after we started the company. But by the way, that's not uncommon for hardware startups. There's a famous company you may know, InvenSense, which builds accelerometers and gyros. It took them 8 years to get it $100 million revenue. Knowles, which make microphones, it took them 9 years to get to $100 million in revenues. So these are the kind of time scales you're looking at for hardware startups. So the lesson learned here at Cepheid was hardware takes a long time, and that's why investors are looking at the team for the team being persistent, being, you know, just hanging in there and really making it all happen, even if it takes a long time. So this was the idea I talked about Cepheid. Our first development was, let's see, where's my mouse? There it is. Was this PCR module. We developed this PCR module. This went into the Smart Cycler, which is for life sciences research, and no FDA approvals, anything like that. But now the same module could also go into our Gene Expert, which was really the diagnostic instrument. So when we built the module, this PCR module, it could be installed in either a Smart Cycler or a Gene Expert. So it halved the development time for the Gene Expert. And for the Gene Expert, we just had to put together all the microfluidics and the cartridge, which I showed you there, which is the disposable cartridge. So this was a strategy about, again, getting revenue as quickly as possible. No FDA approvals required for the first product. So Cepheid today is on the NASDAQ. It's one of Silicon Valley's 100 largest companies, annual revenues of about $450 million. Really good revenue growth every year because they're expanding their menu. A market cap of about actually I think it's closer to $4 billion today. And this is one of the versions of the Gene Expert. It's a single Gene Expert module. This module is actually subsidized by the Gates Foundation. We're going to Africa, remote areas in Africa, India, Southeast Asia for testing for tuberculosis mostly. And the Gates Foundation funds that. The Gene Expert has 16 FDA-approved tests now, and one of the big products they sell is what it's called this Infinity system. There's 80 of these Gene Expert modules in this system, and there's a robotically controlled system that installs cartridges in the various modules and does the testing and then removes the cartridges. So the system is very powerful because it can be either the single module, or you can put this single module in this big system and have the best class system for high volume testing in a modern medical laboratory. So this TB test that's used in Africa and India and Southeast Asia was rated by WHO as better than the current gold standard for tuberculosis tests. So I'm kind of very proud that we have this system that can be taken to the remote areas of Africa. They'll get the same quality tuberculosis test as the best hospitals in the US. So that's a really nice device. I mentioned a large program in developing countries, large pipeline of additional tests under development. And this is the team. I showed the team again. Some of you may recognize this person here. This is Greg Kovacs at Stanford, one of the co-founders of the company. This was the company a year later. And so SciTime was a very nice story. And again, one of the lessons at SciTime was it takes a long time. So then I co-founded SciTime in 2004. Today they have a wide variety of MEMS oscillator products in full production. So what they make is they build a CMOS chip, which does the signal conditioning for the oscillator. And then this is a MEMS oscillator chip, which has a resonant element in it. And they couple those together and build it and have a timing signal that goes out to the rest of the circuitry. Today, they've shipped cumulatively 250 million units. And as I mentioned earlier, these devices are better than quartz crystals in every way. They're lower cost, they're better quality, higher reliability. The frequency stability over time is better than quartz. The temperature and noise performance is better than quartz. And they're currently shipping 1 million units a week to Apple for the iWatch. This was acquired in October by a company called Megachips for $200 million. And the lessons learned, it took 10 years. So we founded the company in late 2004. It was sold in late 2014. It took 10 years to get this to penetrate the market. And again, the lesson learned here is it's difficult to penetrate an entrenched technology and industry. So quartz was entrenched in that industry, and you had to displace quartz in many of these applications. So you had to be so much better than quartz in every way in order to displace quartz. So it took a lot of time. And here's the founding team. So some of you may recognize this person here. This is Tom Kenny at Stanford, who's one of the founders of the company. And Marcus Lutz and Aaron Partridge were actually employees of Robert Bosch. And they left Robert Bosch and joined the company. So then I'll say a couple words about Profusa. So 2008 or so, it was kind of a funny startup, so I'll say a little bit about that later. But Profusa's goal is to build implantable glucose sensors and other chemical sensors other than glucose. So probably over the past 25 years, over $2 billion, we kind of estimate, has been spent to develop such sensors, and they've basically been totally unsuccessful. And in fact, about 10 years ago, NIH stopped funding implantable glucose sensors because nobody was being successful. So Profusa started a totally different concept. And one of the things that, and this is probably mostly an engineering group, one of the things that engineers often do in starting biotech companies is they focus too much on the engineering. And what the founder did, Bill McMillan at Profusa, was start off on the bio side. Think about the bio problem first and ignore all the engineering aspects. And so he hooked up with a very good biologist who was an expert in the foreign body response, Natalie Wisniewski. And they started from the bio problem, and they totally solved the problem. And in fact, they convinced NIH to begin funding implantable glucose sensors again. They've now funded the company over $6 million. And today, the top staff in Profusa have sensors implanted in their body. And when they visit investors or partners, they demo the sensors. They've been in there a year now, and they work perfectly well. It's not glucose yet. It's only oxygen, but it's a good start. And the way the product works in just a very general sense is you implant this piece of plastic. The plastic has fluorescent molecules with the fluorescence changes with the concentration of glucose. And so then you have an optical system in a Band-Aid which addresses the fluorescent piece of plastic, and then it transmits by RF to your cell phone or whatever you want. So it's a very simple thing. It's a little piece of plastic you implant in the body, which is totally compatible with the body. So the lesson learned here is started in about 2008, and the company went more than 5 years before getting any real funding. So working at night, people having their jobs, working constantly over that period of time to kind of put the basics of the technology together so that you could eventually get funding. And so this is sort of an example of the new paradigm that's going on related to hardware startups. And here's the team again. And this person over here is Kristen Helton, who is in the red sweater here. So she's a key founding part of the team now. And most of the team is in the Bay Area, but some of the team is up in the Seattle area. So it's an incredibly good team, and I expect Profusa to have a very good exit also. So when you start a company, there's a huge number of factors which you have to consider. And this is a list of, partial list, probably not even the whole list of things that you really have to consider. It really has to be, that you think of from the very beginning. I mentioned the team. The team is incredibly important. The vision is incredibly important. Of course, the technology, but I would almost put almost first the market. You can have a wonderful technology, but if there's not the market there to accept it, it's not going to be successful. So you have to think about the market from the very, very earliest days, and that's sort of another message I want to leave behind. You can have a great team, you can have a great vision, great technology, but if the market's not there, you're not going to be successful. And if you don't have a way of penetrating the market, you're not going to be successful. But I am going to talk about a little bit more about the team and the vision. So, as I mentioned, for good investors, the team is the #1 factor. A good team, exudes confidence, knowledge, positivity, about the technology and about the market. Startup experience is preferred, been there, done that, but a good advisory board and good mentors can, especially nowadays, can help substitute early on for not having startup experience. Investors do look for business-savvy people on the team, even if they're advisors and mentors. They'll call those people and talk to them and see what the company is all about. For instance, at Cepheid, we had a great founding technical team. There were 6 founders at Cepheid, and all, 5 of those good technical people, me being one of them. But I looked long and hard for a really experienced biotech executive, and I found a guy named Tom Gutschall. I'll tell you, Tom Gutschall made all the difference in the world, having that business experience in the company. And so he's still on the board of directors. And even the extended team is important. At Cepheid, we hired engineers who had already successfully designed and launched biotech products, similar to Novasensor and at SciTime. And I think a lot of times academics having startups, they don't think that much about operations and design for manufacturing. They think about the concept of what they're trying to do. And that is a hugely ignored part of doing startup companies, is having really this experienced engineering team. And I'll tell you, I've seen probably 100 different diagnostic systems for trying to do new diagnostics. And most of the time they look like Legos and kind of a bunch of tubes and wires going everywhere. It looks like a rat's nest. But at Cepheid, this team, and Kristen was part of this team, developed a system. It was elegant, it was manufacturable. They'd already had experience building stuff like that in the past, and it just made a world of difference. We had people leave the company at Cepheid to form companies. They didn't have those people, they didn't hire those people, and really the systems looked like a disaster. So these experienced engineers are so important. So that's that message there. So, and again, the recognition, I've said this multiple times, it takes a long time, and so investors really look at team persistence. And the second thing is the vision. Ideally, the vision is a succinct, transformative idea, including the means and the path for getting there. So yeah, you can have this great idea, but if you don't have a way of getting it to the market, investors aren't going to be interested. So you have to be able to articulate this vision in less than 30 seconds. I mean, people talk about an elevator pitch, 5 minutes or something, but literally, oftentimes you only have 30 seconds. There's a big investor that you want to attract. He's standing there in the room having a glass of wine. There's 50 people crowded around him. You have 30 seconds, to give your pitch. And this is all the pitches that we had at some of my companies, including at Profusa. The vision is a real-time in vivo chemical analysis of your body. And basically, you're just a bag of chemicals. So if you don't know what the chemistry of your body is, you don't know anything about what's happening in the body. And so there's 15 seconds, that's the elevator pitch for Profusa. So the vision, and the other thing is about the vision is if you put the vision in place in the right way in the beginning of the company, it guides the company for many years to come. And I'm kind of shocked that, not being, it wasn't all that smartness, it was a lot of luck. At Cepheid, we had this vision of what we wanted to do. And that vision is the still vision 15 years later. It's still the vision of the company. So the vision is really important because it guides the company. Now, other part of this, the means for getting there. So you have to have a plan for getting into production as soon as possible. And again, at Cepheid, we had the Smart Cycler to get into production as soon as possible. Actually, at SciTime, we had a product within 18 months after founding the company. So especially today when investors aren't really they're very risk averse. So they're really you really have to have a plan that's going to show them, I'm going to be in production in the next 18 months. And today, investors really look for this. So I'll talk about the current MEMS startup environment. So a lot of people say, haven't all the MEMS been invented already? I mean, there's so many of them in your cell phone and all of that. There's a lot of things happening. These are a few of the MEMS devices, MEMS companies I'm involved with. A new kind of MEMS microphone using piezoelectric materials, ultrasonic gesture recognition using MEMS. Low-cost infrared imagers is a very big area. There's a company who's making flow sensors to use in e-cigarettes for determining the dose of nicotine to give to the smoker. There's a new MEMS inertial sensing method with 1,000 times better than the current devices that are in your cell phone. This company was just acquired last year by somebody, I can't tell you who. There's new display technology using MEMS heads to pick and place LEDs onto display surfaces like this. It's a whole new class of displays. That company was acquired by Apple last year for $400 million. The head that picks up the LEDs is a MEMS head. Number of microfluidic and DNA separation, testing for contaminants in groundwater. There's a new MEMS force-sensitive touch technology for touch screens, so that it can actually measure the pressure that you're pressing on the phone. So, so you don't select a certain button until you've pressed a certain force on that spot. There's a headband for sensing sports trauma using MEMS technology. A company that's doing that already has a military version. They've sold 500,000 of these military versions for IED analysis of soldiers who have experienced an IED. So this is just a small example of MEMS, early stage MEMS companies. So there's still a lot of activity going on. So don't believe, that we've invented all the MEMS devices we need. There's a lot to come. And one of the things that's really important nowadays for MEMS, and it's a wonderful help in developing MEMS products, is the mobile is just a fantastic, innovative platform. So these are some devices which you probably know most of these, and some of them have MEMS, some of them don't. But the credit card reader, the Pico projector, a glucose finger stick sensor, even a blood pressure monitor, even ultrasound device, which all just plugged right into a cell phone. So it's a great platform for demonstrating new MEMS technologies. I think one of the great things for MEMS in recent years is the wireless has become an enabler for MEMS. So you can do a demo, fairly quickly on a cell phone. And really, investors today, they want to see a demo before they'll invest in hardware. So that's great. The other thing that's great is bio-MEMS. So probably a lot of you are working on bio-MEMS, and that area is just exploding in MEMS. This is actually, I don't think this is actually considered MEMS by a lot of people, but this is the cochlear implant, which has been around for quite a number of years. Actually, my cousin has a cochlear implant. But it's a strip of parylene that has sensing sites along it, and actually excitation sites along it that excite the different frequencies in your cochlea. And I consider that a MEMS device. So that was a very early one. But now microfluidics for diagnostics. This is a company called CardioMEMS, which builds pressure sensors that are implanted in the body, and you can measure. They're actually starting to implant them near the heart nowadays. This is again, very simple kind of devices. This is a inflatable mattress or sub-mattress underneath the main mattress. And if you have the right system, you can measure the pressure in this mattress, and you can tell respiration, heart rate, obviously whether the patient's in bed or not. So this is starting to be deployed in elder care facilities. There's many, many companies today that are making various medical Band-Aids that have all kinds of different functionalities, EKG, pressure or temperature, accelerometers so they can detect falls, heart rate, respiration rate. These Band-Aids are becoming very, very popular. This is a company called Ion Torrent, which makes a pretty simple CMOS MEMS chip for doing very rapid DNA sequencing. So they can sequence a human genome in a few hours. And this company was acquired for, I don't know, a couple $100 million, I think, by Life Technologies. This is a company that makes explosives detection systems for airport screening. So it's actually a MEMS microfluidic chip. They suck in air from the passenger, and they analyze parts per trillion, explosives in this little MEMS microfluidic chip. This is the Profusa device. And believe it or not, one of the things I really like, and you may not be aware, is that there are a number of companies around the world now that are making artificial retinas. So they're actually allowing blind people, certain types of blindnesses that blind people can see. So we're going from deaf people, allowing deaf people to hear, to blind people to see. And it's just incredible impact. These artificial retinas that they have right now are fairly low resolution. They're like 64 pixels. And they were allowed by the FDA to do sort of clinical trials on a few people, but then they had to remove them. But the patients who received these, they didn't want them removed. They could see, for the first time, even though it wasn't very good quality, they didn't want them removed because it was changed their life. So there's many, many other areas: drug delivery, chemical sensing, protein panels, cellular manipulation, lots of other implantable sensors, sports monitoring, advanced fluidics. The biospace is just opening up whole new opportunities for MEMS. It's a very, very exciting place to be in. So I have a few more minutes here to talk about the entrepreneurial outlook for the future of MEMS. So in the last 10 years, there's been two major economic crashes. I guess it's been a little bit more than 10 years now. But what's happened is that as a result of these crashes, venture capital has severely retrenched for hardware. So it's almost impossible for a hardware company to get a Series A investment anymore. I like to say that actually, I'm with the Band of Angels I mentioned. At Cepheid, we pitched to the Band of Angels in 1997. And I would be embarrassed, to give that same talk today because companies are much more sophisticated. Investors are looking for much more than we had when we gave that pitch to the Band of Angels in '97. And I know that if I gave that same pitch today, we would never get funded. We got funded in '97, but today it wouldn't happen. And actually, Cepheid was one of the band's most successful investments. So it's severely retrenched, and especially for hardware companies. But that doesn't mean that the entrepreneurs have gone away. Entrepreneurs are still very, very active. I see a lot of hardware companies. So they haven't retrenched, but they've gotten much more scrappier. They just hang in there for longer periods of time. They do things at night. They do things on the side. They just managed, as I mentioned with Profusa, 5 years of basically, people working on the side, kind of friends and family, little bits of funding, but not really very much funding. And people have to be just much more scrappier, much more hanging in there. So some of the changes that they've made is, since you can't get a Series A, there's much more use of angel investors. So the angel investment community has really sort of stepped in where the traditional VCs have gone away pretty much. Also much more earlier partnering with large companies. I think large companies have been recognizing that the Series A isn't there, hardware startups aren't happening. So actually they've also stepped in, and they have their own venture arms. They will invest in small companies. And also they're doing more NRE. So one of the companies, this ultrasonic gesture recognition company that I'm working with, they can't get a Series A, but actually they've gotten $1.5 million from a very big cell phone company to do some NRE for them. And it's totally NRE, so it's not dilutive. There's no stock involved. So there's a lot of that happening, which 5 or 6 or 7 years ago would never happen. But today it's a very big program. But what this means is there's so much activity. Entrepreneurs haven't gone away. There's a lot of entrepreneurs. I mentioned the Band of Angels sees 50 deals every month, new deals. So the funding bar for these new startup companies has really been raised, even for angel investments. These are some of the conditions that kind of we look for. Ideally, the company should have an experienced startup team. But one of the great things about angel investors is they'll do a lot of mentoring. So you can go to angel investors early on and say, hey, we want to start this company. And there's one company that I invested in. It was a very successful investment, solar cell inverters. And there were a couple of angel people who mentored that company for 2 years before they even put them in front of potential angel investors. So, very little money, but mentoring them for 2 years and then brought them to angels. They got a very good investment. So, so they do a lot of mentoring, and that's a good thing. Ideally, you really should have developed products, prototypes, or very, very good demos. So at Cepheid, I mentioned when we pitched to the Band of Angels, we had no prototypes, we had no demos, and like I say, today that company wouldn't be funded. Every hardware company we see has some kind of really good demo that they can show, and you can envision that it's kind of close to production. Arrangements with customers and collaborators. So as I mentioned, people are going more and more to big companies, potential acquirers, and engaging with them, engaging with their engineering people, engaging with their venture people, finding out what they need. So there's more engaging with these big potential customers or acquirers, that's happening today. And by the way, it used to be the dream when you start a company, you're going to do an IPO in a few years. Well, that dream, it happens to about 1% of startups, or maybe even less. And so so people are really now more focusing on, we're going to get acquired, so we're going to put relationships in place with potential acquirers. And a lot of times with many new startup companies that are happening now, they're purposely structured, and they have relationships with industry people who can arrange for the company to get acquired in a fairly short period of time. IP should be well underway, so you should already have IP written, filed, obviously, or ideally. And a typical kind of pre-money valuations of 3 to 5 million, you're typically trying to raise 0.6 to 1.2 million. That's kind of a typical angel deal. So I want to talk about, we're so fortunate the way the US system is established right now for entrepreneurs. There's many people all over the world, as you know. I've given talks in China. Europe is trying very hard to be more entrepreneurial. Singapore government has put a lot of money into their companies to try to generate an entrepreneurial environment. But the US has such a great entrepreneurial environment. And I would just want people to sort of realize that Singapore has been very, very unsuccessful. Just as one example, I used to consult with one of the government agencies there. They put a lot of money in, but the problem is, in Singapore, if you start a company and you fail, there's a huge black mark on your career. So who's going to want to risk that? Because startups fail for many reasons. So if you're going to get this black mark on your career, why would you want to take this big risk in starting a company? So you have to have a culture that accepts failure, because a lot of startups failure, and I mentioned, my first startup was a total failure. So in the US, there's a powerful entrepreneurial culture and infrastructure, and it's a business culture which embraces risk, which is just kind of what I'm talking about. In much of the US, there's little fear of failure and little stigmatism for failure. So people are incentivized, to take that risk. I can tell you that every Starbucks in Silicon Valley, there's a discussion, maybe even 2 or 3 going on about startups. It's just all over the place. And I'm sure it's the same way in Seattle. I mentioned this about the Band of Angels, 50 deals. It's basically like, at least in our area, it's like an epidemic. And I know that all over the US, people are trying to be more entrepreneurial. UW is trying to be more entrepreneurial. I'm an ex-MIT alumni, and they're trying to be more entrepreneurial. And it's a lot of fun for entrepreneurs. One of the most important things in the US that I think makes a huge difference, and I can give examples, and I won't right now, but there's this huge collaboration and partnerships in the US between industry, university, and government. I actually learned from Bruce Darling this morning 2 more industrial academic programs that are underway I didn't even know about. But there's this really tight collaborations, and this makes a huge difference, and it's not that common, you know, in other parts of the world for different reasons. You know, so most US technology professors are involved in some way with industry, you know, and even many of them, professors and students, have started companies, you know, so that's already kind of underway. 5 out of 6 of my startups have involved industry professors and or students, Berkeley, Stanford in particular. Major universities have startup contests for the students, so they, you know, they get a little team of students and they start a company, and then they have a contest and somebody wins that contest that year. It gets people thinking about being entrepreneurial. And the other thing is, and actually I've been impressed with UW about this aspect, is major US universities now have very progressive policies for easy licensing of IP from professors and students to startup companies. So I think that's, I mean, that's been going on maybe quite some time at like Stanford and Berkeley, which I'm very familiar with. But now I think in Seattle, it's the same way, and many universities now in the US, it's the same way. So that really makes spinning off technology from a university much easier. And of course, all major high-tech companies now have venture investment groups. So you get to learn, you know, this Qualcomm, Intel, they have venture groups. So you can go and talk to those people and you can gauge their interest. Also, there's incredibly effective funding of research and development by the US government, DARPA, NSF, NIH, DOE. And I've been to a number of DARPA meetings where they actively encourage inventors, let us be your angel financing, which is really an incredibly far-sighted thing for the government. And investors like government money because it's non-dilutive, so it doesn't dilute the stock. Also, sophisticated infrastructures in major US technology cities, and of course Seattle is one of those startup incubators, angel investors, technology and business in mentors, wafer fabs and foundries. So I just heard yesterday that a huge fraction of the people using the fab at UW are startup companies and other businesses, so actually industry involved. So the majority of the customers at the wafer fab here are industry. Consultants, you know, venture capital, experienced startup attorneys, and that's really important. Consultants, you know, human resources, et cetera, et cetera. So lots of infrastructure for starting companies. It's practically turnkey now to start a company. You go to a law firm which is experienced in startups. They have a boilerplate that you fill in the blanks, you know, how you want to organize the company. All these lawyers have had experience with startup companies. It's practically turnkey today to start a company. And I think also very importantly, there's thousands of previously successful entrepreneurs who are anxious to help, you know, to start, to lead, to mentor, to help, and to invest in new startup companies. So a lot of the people in the Band of Angels are people who have started companies in the past, and they just want to help and mentor new companies, and they're actively trying to do that. So you have all these resources. And so today's entrepreneurial environment worldwide is really experienced, dynamic, vibrant, really intense, and it's growing dramatically. So how does all that impact MEMS? So I'm a MEMS guy, even though I now invest in a lot of other things other than MEMS, but I really like the MEMS area. So sort of a summary, the MEMS has really grown dramatically, as I mentioned earlier, from 1% to 4% of semiconductor shipments. And this percentage is growing. And I think in a few years, it's going to be 7 or 8% of the semiconductor industry. Many MEMS manufacturers have shipped over 1 billion total devices. And today, these same manufacturers are shipping greater than 1 billion devices per year. There's probably about 6 companies that are shipping more than 1 billion devices per year. So, and huge new opportunities for MEMS have only recently started. Ubiquitous wearables, consumer, mobile electronics, healthcare and medical, environmental and structural monitoring. This is all part of the Internet of Things. So huge new opportunities there. Also, foundries, large electronics companies, and investors are scrambling for new sensors and new MEMS companies. You know, Apple and Google, for instance, have begun hiring huge number of MEMS engineers. My professor friends at Stanford complain that all their students are going to Google and Apple. And Google and Apple are also buying lots of early stage MEMS companies. So these big companies are really actively looking to get more involved in MEMS. So I believe the opportunities for MEMS have only scratched the surface, and really the age of MEMS and sensors has only now just kicked off. It's only now on that hockey stick part of the curve. So it's a very exciting time to be involved in MEMS. So thank you all very much, and I've enjoyed being here. Thank you.
Well, thanks very much to Kurt for this great talk. We have time for some questions all the way in the back.
Hi, I noticed you've done a couple of companies, some of which have been design wins, and others have been more disposables. So could you comment from your perspective on, you know, the pluses and minuses of, like, you know, side time, which is a design versus disposables?
So actually, when I founded Novasensor was really relying on design wins. So we would build a chip for a customer, and then we were sort of second in line. So our chip had to be successful, and so then we would sample that chip to the customer, and then he would put it in his system, and then that system had to be successful for Novasensor to be successful. And so it's kind of, you're relying on your customer, you know, to be very successful. So actually, when I left Novasensor, I said, I don't want to do that. You know, I don't want to have to rely on my customer. So at Cepheid, we sort of started from scratch. We built the whole system. We built the disposable. We built sort of everything from soup to nuts. And obviously, Cepheid was my most successful startup. But at the same time, it takes a lot of time to develop, you know, those sophisticated, it's almost like a whole infrastructure you have to build, you know, the instrument, the disposables, you know, the support for the customers. Whereas in a design win, you just work with a customer and you'll build the part for the customer. So building the part for the customer is easier in a sense, but it's, and faster maybe in some ways, but, and it takes more money to do the kind of soup to nuts thing. So both could be successful, but probably the ones that had the best chance for doing an IPO is probably the whole soup to nuts kind of idea. Does that sort of answer the question? Okay.
Along with your soup to nuts thing here, when you have a long development time, it's usually because you're building tools along the way to finally build the final product. I would think there would be a big market for the tools to bring in money to carry along to get to the final end of this thing, and that should be part of what you get out there and push.
That's actually a good idea. I sort of hadn't thought about that idea, but a lot of people are building tools, and I think the tools space is, especially for MEMS, you know, and I was really impressed with this company, LuxView, that builds this pick-and-play system for the LEDs. It's really a tool that they're developing. And I don't know whether they're going to sell that tool. Probably now they're owned by Apple, they won't.
Now that you get a patent in a year, presumably you're patenting what you're doing as you're going along. And so I would think that the tools would be in a patent-protected space, so you let them use the tool to develop something that you also give them the rights to for, of course, a few dollars. And so your tool would be protected.
But very often those tools are so custom, you know, to a particular company that's developing them. I mean, if you can do that, I think that's a great thing. But oftentimes it's too custom for the company that develops it.
So I see a lot more questions. Maybe I'll continue there. And then.
Thank you for the talk. I really enjoyed it. I see that you did not touch base on using MEMS for power harvesting. Is there a reason, and what's your opinion on the field?
No, actually, that's very good question, very good point. I think MEMS for energy harvesting is going to be very big, but I don't think anybody has found like the magic bullet yet. I don't think people have discovered that yet. There's a lot of activities in those areas, and there's this Power MEMS conference that's held every year. So I do think it's going to be a huge thing, and especially for the Internet of Things. You know, the big problem there, obviously, as you know, is the power. And I think it's going to happen, but I don't think people have, and this may be an opportunity for people in this room, I don't think people have discovered yet the ideal MEMS, or not even MEMS, it could be anything, but the ideal power harvesting technology.
Okay, 1, 2, 3, 4. So let's start there.
Yeah, can you comment on the integration of MEMS with CMOS? I mean, it's all your cycle time is different dies. Do you see a trend? It's going to be big thing, or just still going to separate ways?
Yeah, that's actually a really good question. People early on did a lot of integration of MEMS analog devices, MEMS with CMOS, and then, but that can cause big problems because it's very hard to optimize your circuitry in later generations and without changing the MEMS, and because they're all integrated together, so it kind of makes the circuitry and the MEMS development, it ties them together. If you have two chips, it doesn't, they're independent of each other. So actually a lot of in recent years, they've been sort of de-integrating. In fact, even ADI today has a separate MEMS chip and a separate CMOS chip. And I think in the future, as people do more of this chip stacking, where they have a logic chip, a memory chip, an analog circuitry chip, an interface chip, I think they have a MEMS chip. And people are learning much better TSV ways of interconnecting chips in a with very low parasitics and things like that. I think it's going to really move more toward having a separate MEMS chip and a separate CMOS chip, and less integration of CMOS with MEMS.
Okay, I think Richard.
You mentioned a typical angel deal today is about $300K to $1 million for 10 to 20% of a company. So what will be the expected return and years of exit, typical?
For hardware, as I've said many times, you have to be patient. So I think we're typically looking more for an acquisition exit. So, and every deal, for the next few years, people are talking about, who might acquire this and whatever. So I mean, I typically try to look at deals that are maybe 4 years out there, 5 years out there, and it takes longer to get to an IPO, but the other thing about, actually, I should mention this. When you organize a company and start a company, you really should organize it in such a way that it's capable of doing an IPO, because then it has all the infrastructure in place that allows it. Okay, you could do an IPO, but very likely it's not going to. But having all that structure in place makes it much more valuable for an acquisition.
4 years, what would it be like the return you would be interested in?
Okay. So I mean, traditional VCs, they look for a 10x return on their investment. I think I'm more happy with 4 or 5 as a small angel investor. So, and I think I've sort of averaged maybe about 5 or 6 or something like that.
Okay, maybe let's do 2 more questions here, maybe one here.
So you mentioned Nova Sensor in 6 months had 50,000 units, but didn't have a fab. Can you talk briefly on the approach?
So we borrowed a fab. So we convinced the company to let our people work in their fab. And then while we were working this fab, we started building our own fab. So, and then we transferred the process over. So, even today, there's still lots of fabs in Silicon Valley, so you can sort of make those kind of arrangements, and people are generally open to those kind of arrangements. But other times we've used, especially for building prototypes, the Stanford fab and the Berkeley fab are just perfect for building prototypes in the Bay Area, and I'm sure that's where you are working, right now at UW to serve that same kind of function and capability.
Okay, Anand.
A very interesting talk. Wondering if you have any thoughts on where you think MEMS research is headed on the academic side of things in a university setting for the next 20, 30 years. And let's say if an electrical engineering department was going to hire someone in MEMS, what would an ideal candidate be like? Just so it should cover, in some sense, both academic research and probably, lead to something useful eventually.
So I have a crystal ball in my brief suitcase here, but the huge thing that I think is important about MEMS and why people are snatching up MEMS people is because they're so multidisciplinary. MEMS, you have to worry about, electronics, you have to worry about mechanics, you have to worry about complex packaging, signal conditioning, algorithms. I mean, MEMS, that's one of the huge values. That's one of the reasons I love MEMS so much, because it's so multidisciplinary. And that's what a lot of people are looking for, and that's why looking for people who have that multidisciplinary capability. I think that's what's really valuable.
Okay, well, the very last one, and then we'll wrap it up.
You had just alluded to that you've seen a lot of medical diagnostic companies, and I got the impression that they haven't necessarily been successful. Is that because they've missed the mark? Is it an integration issue? Is it a market issue? And do you see these things changing with the move to ACOs?
ACOs?
I'm sorry, the way that we pay for healthcare is
Oh,
value-based
okay.
versus the fee-for-service.
I think it's more, with medical diagnostics, it's more menu, it's a menu problem. So even when at Cepheid, when we came out with our first gene expert system, we had one FDA-approved test on the market. Nobody's going to buy an instrument and sacrifice laboratory space for an instrument with only one test. And so you really have to have a menu of tests. And then it takes many years to put that menu of tests together. So really even sales at Cepheid, revenue at Cepheid, didn't start to take off until the menu was at like 3 or 4 or 5 tests. And so it takes time, and time is money to develop all those tests. And then people finally say, oh, I have this test, I have this test. Now I'll sacrifice lab space, bench space, to put that system in. So I think that's one of the problems. People are going more or looking more at point of care systems, which are very small handheld systems. And most of the 6 companies that I've sort of dealt with, they're all point of care systems. I think those have the opportunity for taking off quicker and for being less menu dependent. People haven't been real successful yet on those point of care devices. I mean, there's the one example, iStat, which is now owned by, I think Abbott owns iStat. That's been really the only super successful point of care system.
Okay, well, I think we'll have to wrap up now,
Okay.
but I'd just like to thank Kurt very much again for the great presentation.
Thank you all.
Coming up here.